NASA's OSIRIS-REx spacecraft has achieved orbit insertion around the near-Earth asteroid Bennu. The 492-metre-wide space rock has one of the highest known chances of hitting the Earth, with a 1 in 2,700 chance of impacting the Earth sometime between 2175 and 2199. If it were to hit the Earth, the resulting impact would be the equivalent of 1,200 megatons of TNT. 101955 Bennu is what's known as a carbonaceous Apollo group asteroid. That means it's a near or near-Earth object with an orbit that intersects with and crosses Earth's orbit around the Sun. Bennu is what astronomers call a B-type carbonaceous asteroid. They're generally similar to regular C-type carbon asteroids, but with surface spectra suggesting anhydrous silicates, hydrated clay minerals, organic polymers, magnetite, and sulfides. Launched back on September the 8th, 2016 from the Cape Canaveral Air Force Station in Florida aboard an Atlas V rocket, the 2,110-kilogram OSIRIS-REx spacecraft arrived at Bennu in October 2018. The spacecraft spending 3 years orbiting the asteroid and mapping its surface and geology, studying its evolution, composition, chemistry and mineralogy. The orbital insertion maneuver, carried out some 110 million kilometres from Earth, set a new space exploration record for the smallest object ever to be orbited by a spacecraft. Inching around the asteroid at a snail's pace, OSIRIS-REx's first orbit marks a huge leap for humankind. Never before has a spacecraft circled so close to such a small celestial object, one with barely enough gravity to keep a vehicle in stable orbit.
It's almost lost in the news of New Horizons encounter was the arrival of the OSIRIS-REx spacecraft at asteroid Bennu. It's been a 2 billion kilometre 2-year journey to catch up with this asteroid. They've been approaching it for the last few months, getting closer. But on New Year's Day, actually entered orbit in an incredible, very tiny orbit, quite close to the surface, and actually orbiting at a speed of just 6 centimetres per second. So it's probably the tiniest and slowest orbiting object, and certainly the smallest object that's ever been orbited around.
That's Glenn Nagel from NASA's Deep Space Communications Complex near Canberra. OSIRIS-REx is circling Bennu at just 1.75 kilometres from the asteroid's centre. That's closer than any other spacecraft has ever orbited a celestial body. The previous closest orbit for a planetary body was set back in May 2016, when the European Space Agency's Rosetta spacecraft orbited about 7 kilometres from the centre of the comet 67P Churyumov-Gerasimenko. The 1.75 kilometre distance is considered comfortable enough to keep OSIRIS-REx locked to Bennu, which has a gravitational force just 5/millionths that of Earth. The spacecraft will remain in orbit around Bennu through to mid-February, circling the body at a leisurely 62 hours per orbit. OSIRIS-REx principal investigator Dante Loretta from the University of Arizona in Tucson says the probe's 8-second burn of its thrusters, which placed it into orbit, meant the navigation campaign was now coming to an end, and the scientific mapping and sample site selection phase of the mission is now beginning. Now that the OSIRIS-REx spacecraft is closer to Bennu, physical details about the asteroid will leap into sharper focus, and the spacecraft's tour of this rubble pile of primordial debris will become increasingly detailed. OSIRIS-REx Flight Dynamics Systems Manager Mike Maru from NASA's Goddard Space Flight Center in Greenbelt, Maryland, says the orbital design is highly dependent on Bennu's physical properties, such as the asteroid's mass and gravity field, which simply weren't known before the spacecraft's arrival. Up until now, scientists have had to account for a wide variety of possible scenarios in their computer simulations just to make sure they could safely navigate the spacecraft so close to Bennu. As the team learn more about the asteroid, they're able to incorporate more information to hone in on the final orbital design. Having completed a preliminary survey of Bennu with flybys of the South Pole on December the 16th, the spacecraft moved to a safe holding pattern 50 kilometres from the asteroid, giving the navigation team a chance to regroup and prepare for orbit insertion. Next, Lockheed Martin engineers who built the spacecraft programmed it to begin moving back to a position about 15 kilometres over Bennu's North Pole. That positioned the probe for 3 burns of its thrusters over the course of 10 days, designed to place the spacecraft into orbit. Even though OSIRIS-REx is now in the most stable orbit possible, Bennu's gravitational pull is so tenuous that keeping the spacecraft safe will require close monitoring and regular adjustments. You see, the gravity of Bennu is so small, forces like solar radiation and even thermal pressure from Bennu's surface become much more relevant. They can push the spacecraft around in orbit much more than if it were orbiting, say, the Earth or Mars, where gravity is by far the dominant force. So the OSIRIS-REx navigation team will use trim maneuvers to slightly thrust the spacecraft in one direction or another to correct its orbit to counter these small forces. Meanwhile, mission managers have developed three-dimensional models of Bennu's surface based on a preliminary global imaging and mapping survey of the asteroid's terrain. This means that instead of celestial navigation, they'll now be able to rely on landmarks identified on Bennu's surface to track OSIRIS-REx, and ultimately guide the spacecraft to a sample collection site clear of boulders and large rocks. Another crucial objective involves getting a better handle on Bennu's mass and gravity, features that will influence the planning of the rest of the mission, most notably the touchdown on the surface for sample collection in 2020. In the case of Bennu, scientists can only measure these features by getting OSIRIS-REx to fly very close to the surface to see how its trajectory bends from Bennu's gravitational pull. In late February, the spacecraft will perform a series of close flybys of Bennu for several months. These are designed to collect high-resolution images of every square centimetre of the asteroid in order to help select a sampling site. Then, by the middle of 2020, the spacecraft will briefly touch down on the asteroid's surface to retrieve its first samples. OSIRIS-REx is slated to leave Bennu's orbit in March 2021, with a sample return capsule being jettisoned for a parachute landing in Utah in September 2023.